Linear functions. We'll define functions later on. Pretty much right now is look at it as a linear equation. We know a linear equation from the graph. The graph of a linear equation we talked about, there are three of those. It could be horizontal, it can be vertical, or it can have any other slope. Notice a linear equation, the graph of it doesn't have a bend or a curve or a point or anything. Those are linear functions, the linear equations. It just has x and y, nothing else around it. No powers, no special operations. Nonlinear functions. What do you think nonlinear means? Not a line. So it's not a line. So it could look like this. And there are a whole bunch of other ones. Those are nonlinear functions. So linear functions have the equations of linear equations have this form. Y equals mx plus b. Because typically when people ask, give me an equation of a line, the first thing you think about is y equals mx plus b. Even though there are two other ones we're going to talk about in this class. What does little m represent? Little m represents slope. So in other words, whatever is in front of the x, whatever is in front of the x is your slope. And b represents it's a constant, so it's a what? It's the y-intercept. So if it's just a number, it's the y-intercept in your equation. All right, so let's look at a couple of examples first of equations that we've talked about already. Horizontal lines and vertical lines. Oops. Let's first talk about those because we get those out of the way so we know what to look like. We know the y-intercept of this one. What's the y-intercept of this one? The y-intercept is 0, 3. Remember, the y-intercept is a location. It's a point. If you said 3, you got it wrong. It's a location. 0, 3 is the location. What's the x-intercept? Does not exist on a horizontal line. We're looking at this one still. What's the slope? Zero. So whenever you see a slope equals 0, you know it's a horizontal line. Or conversely, if you see a horizontal line, you know the slope is 0. And I'll show you why in a second. So this is the y-intercept. So in this one, what is the y-intercept? Does not exist. What's the x-intercept? 4, 0. What's my slope? Undefined. Do you think you can come up with a way to prove to me why this is a slope 0, why this one's undefined? What do you need to find a slope? We just did it in section 1. You need 2 points. So find me 2 points on this graph. Do we have a point already? Yeah, we have this point here. Give me another point. What's that point? We sort of use some 2, 3. So we have 2 points here, 0, 3, and we have a point 2, 3. So let's find the slope. It's y2 minus y1, x2 minus x1. x1, y1, x2, y2. So y2 is 3, y1 is 3, x2 is, and x1, 3 minus 3 is 0, 2 minus 0 is 2. How many times does 2 go into 0? 0 times. So there's how you prove that. So we know the slope. We know that it belongs to a horizontal line. And we also talked, what's the equation of that line? Of a horizontal line? You're right. Y equals mx plus b. But m is what? What's the y-intercept? 3. So it's just y equals 3. So a horizontal line does not have an x value. So the equation is just the y-intercept. So y equals b is the equation of the line. So these 3 things are related. Slope 0, horizontal line, and y equals b. Those are all and horizontal lines. It all defines horizontal lines. So let's look at what defines a vertical line. We need 2 points. We have the first point is at 4, 0, and the other point is at 4, 1. So the slope this is x1, y1, x2, y2. What's y2? 1 minus y1 is 0. x2 minus x1. 1 minus 0 is 1. 4 minus 4 is 0. How many times does 0 go into 1? Infinitely number of times. So that's why we call it undefined. It's what we call an indeterminate amount. You can't tell me how many times. It's infinity. So if your slope is undefined, then we know it's a what kind of line? It's a vertical line. What's the equation of a vertical line? Remember, we can't use this equation on a vertical line. Why? Well, no, because there is no y value. It never crosses the y-axis. So that doesn't exist. So you cannot have a y-intercept. So the only thing you can have is x equals where it crosses. In this case, the x value of the x-intercept. Because we're going to define a vertical line is not a function. A horizontal line is a function. Vertical line isn't. We did slopes already. We just talked about horizontal and vertical lines. Okay, we have one more topic, one more section. I mean, here's an example for this one. Example 2. Graph these. Graph those. And then all we have left in this section are example problems. So what's the first one going to look like? The vertical line crossing through -2. So it looks like this. Since there's no y's in there, it can't cross the y-axis. The other one, it's a horizontal line crossing through y at 3. So it's a horizontal line. Perfect. How would you graph this one now? So first up, plot the y-intercept, which is the b value. So in this case, b is equal to -1. So we have a point at -1. From that point, the b value, follow the slope, m. So since m is 2/3, remember, the slope is whatever's in front of the x. It's +2, so I'll go up 2 and over 3. And then connect the dots. That's all there's to it. That's if I gave it to you in this form. There we go, written down. What if I gave it to you in this form? Three x minus 6y minus 7 equals 0. This is example 7. Graph this one. Here are the steps. What's my first step? Put into y equals mx plus b, or solve for y. Solve for y first. So in order to solve for y, what do we got to do first?
X equals 0.
No. You're doing the intercepts now. We're doing the intercepts. We're solving, putting this form.
Um,
So we want y to be positive, right? So let's move this one over. Let's add 6y to both sides. So we have 3x minus 7 equals 6y. Yeah, then since we wanted to solve for y, we have to get rid of 6. Divide each term by 6. Do them separately. Because now we have y equals 3 over 6x minus 7 over 6. 3 over 6 can be simplified to what? 1 over 2. Not 2. 1 over 2. So we have this. Again, this one is not a fair one. Because my slope is what? 1 over 2. What's my y-intercept? What's my y-intercept? 0, negative 7 over 6. That negative goes with it. So if we were to graph this, negative 7 over 6 is the same thing as negative 1/6. So it'd be somewhere there. That's my y-intercept. Then I follow the slope. I go up 1, which is here, and then over 2. Then it connects the dots. How do I know my graph's supposed to be in this direction instead of down? My slope is positive. That's very true. So if the slope is positive, it goes up as you go left to right. If it's negative, it goes down. To help you memorize all those, we use slope face. If the slope is positive, it looks like that. Left to right, it's going up. If the slope is going down, it's negative, it's going down from left to right. If it's undefined, it goes up and down. If it's 0, it goes left to right. That's the easiest way that you could do to memorize what your slopes really mean when you do them. All right. That's all we have left tomorrow. We'll do some application problems, some examples, and then we'll start the next section.